Hello, this is Mr. Buss, and the intention of this video is to just kind of show students the activity we did called the paper DNA activity in case you were gone. So just want to make sure that you were able to kind of see what we did in class. And so I don't have the document pulled up on my iPad right now, but of course you have access to that. So, the document kind of describes what everything is here. We've got these little cutouts, and they just represent parts of a nucleotide, a DNA nucleotide. And so I know these are the phosphates, okay, the PO4s. And then these are going to be the sugars, these little designs here. And then these are the nitrogenous bases. And so there's 4 different nitrogenous bases: adenine, thymine, guanine, and cytosine. And so that's why there's the 4 different colors here. And they're very similar shape, but they have slight differences. So like you have to look on the shape has this one has like a slightly convex, but it's got like 3 sides to it. And then this would fit, with this yellow one that has a corresponding match. So your A's and T's and G's and C's. So here's another example where you have like a convex and a concave match. And this one's more of a smooth match. So you can kind of see how the bases match up. And then the sides of the DNA, though, the sugar phosphate backbone, we'll call it. So here's a sugar and a phosphate. And like a single nucleotide is like 1 phosphate, 1 sugar, and 1 base. So that would be like considered a single nucleotide. 1 sugar, 1 phosphate, and 1 base. And then as we build the strands, we have to connect more sugars and more phosphates. Of course, the way I'm building it isn't exactly the way it would be built in the body. I'm just kind of using the most efficient building method here of just kind of grabbing phosphates and throwing them onto sugars on one of the sides. And I think we built a total of 6 in class. So 1, 2, 3, 4, 5. Let me get one more on there. 6 sugars and 6 phosphates on each side. And then you kind of, to make the strand, then you bring in some of these bases here then, of course. And you attach them with a little notch cut out to the sugars. Okay, and so that is one strand, one side. I'm just kind of randomly putting the A's, T's, G's, and C's on there. And then to build the other side, of course, then you find the complementary matching bases. And so there. And then I'll need there. And I don't think I used the exact right number of A's, T's, G's, and C's. I think, here, let me do this. I feel like if I do this, then I'm going to have an equal number of A's, T's, G's, and C's as it says to do on the document. Yeah, that's going to be better. And one more yellow. Here we go. And then just to build the other strand, we're going to need to have, again, the alternating sugars and phosphates. And so it's a pretty easy activity to do. It's a good kind of like day 1 studying the DNA molecule activity. Just gets us kind of familiar with the base pairing rules of A to T and G to C. Apples grow on trees, cars park in garages was the kind of the way we memorize that if needed. And then also just the idea that adenine and thymine, this is part of the document, the notes or information. Adenine and thymine have 2 hydrogen bonds between them. And guanine and cytosine have 3 hydrogen bonds between them. And when we refer to DNA, we a lot of times refer to it as a ladder structure. And you can obviously see why that's the case. Of course, if we're looking at a more of a 3-dimensional DNA molecule, it might be more of a twisted ladder shape or something like that. Got a few extra bases there. So this would be an okay screenshot if you were a distance learner for this and you didn't have access to the materials. You could take a screenshot of this and label the phosphates and sugars and the A's, T's, G's, and C's here. One thing that I do look for when I grade these is make sure that you understand what a nucleotide is. Again, 1 nucleotide is 1 sugar, 1 phosphate, and 1 base. So there's 1 nucleotide, right? And here's another nucleotide, right? The nucleotides are the combination of 1 sugar, 1 phosphate, and 1 base. And then the nucleotides are what match up with each other. So complementary, we use the phrase complementary nucleotides match up with each other. So that was the paper DNA activity we did. Not too crazy, but again, kind of shows that overall ladder-like ladder-like structure with the bases matching up in the middle, where the hydrogen bonds are between the bases. And then the sides are the sugar phosphate backbone of the ladder. Of course, we can't show the three-dimensional shape of this because it's a paper cutout activity, but it's pretty good for what it is. Hope that helped.